Hi, it's the TI84 guy. I decided to create another video on the new PSAT to again kind of demonstrate how easy it is to answer some supposedly difficult questions if you know how to use your TI84. All right, so this question here. I'm sure for a lot of students, if you haven't taken physics, would probably be confusing because it gives you three equations that you're supposed to that you're allowed to use, but it doesn't tell you which one specifically to use, right? Um, so if you know physics, you kind of know you can probably guess which one you need to use. But if you don't know physics, you're kind of going like, well, I'm not sure which one to use. But one of the things that I would say, and I've looked at the questions on the new PSAT and also questions from the new SATs. Um, Basically, whenever they're asking you to find a maximum, and in this case, we're trying to find the maximum height, and the other question is find the time that it takes to reach the maximum height. You should know if you've taken Algebra 2 or Algebra 1, that you're going to be dealing with basically a quadratic, right? So if you look at these equations, this one is not a quadratic. This one here definitely is a quadratic. If you look, the quadratic is in terms of time, t squared. And in this one, it has v squared, but in this particular case, v is just a constant. It's the initial speed. So it's not quite what we're looking for. So just knowing that when they're asking you to find a maximum or a minimum, that you're probably going to be dealing with a quadratic, I would start with this question or with this equation here. Now, they they tell you that the initial speed, or v sub naught, is 100 meters per second. And they also tell you that the acceleration, or g, is 9.8. So I've drawn a little picture here. It's not the best, but it doesn't have to be the best. It just needs to illustrate an idea, general idea. So basically, we know that if you look at this equation, that the coefficient in front of the t squared term is a negative 1/2 g, right? So we know that the parabola that's created is going to be an upside down parabola. And that makes sense, right? So if you shoot an arrow, it's going to go up, 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 and then it's going to hit a point, a maximum, and then it's going to start to come down, right? So the question is, how long will it take for the arrow to reach this maximum, right? How long? They want to know this, how long, but they also want to know how high does it reach, right? What's the maximum there, right? So if you know how to use your graphing calculator, this question is really simple, right? So the only thing that you need to do is they've given us the values for the initial velocity, v sub naught, of 100, and they've also given us the acceleration constant of 9.8. So all we have to do is substitute those in, and then we can graph this. So now I'm going to go and I'm going to grab my TI84. I'm going to turn it on, and I'm going to go here. Let me get rid of this. This is from the last video. And what we're going to do here is we're basically going to enter this equation with the constants in there. Okay, so in this case, y is going to be h, and we're going to use x for t. So v sub naught is 100, so we're going to go 100, and where you see a t, because the only variable that you can graph is an x. You can't graph any other variable. So even though this is a t, you can only graph x's in your calculator. So we're going to make this an x. And then we're going to go minus, and I'm just going to make this 0.5. 0.5 times the acceleration constant, 9.8. And then I'm going to go x squared. So here's what my equation looks like. Okay, So 0.5 times 9.8 times x squared. So now we're pretty much done with this question, okay? The only thing we have to do now is we're going to graph it. So I'm going to hit the zoom key, and then I'm going to go option 0. So I'm going to go down to zoom fit because I want to put this entire thing on the screen so we can see it. So I'm going to go zoom fit, and there goes my parabola. Okay, now the regular screen goes from a -10 to a +10. So I'm going to make this a little wider so that we can see the entire parabola. So I'm going to go to the window, and I'm going to make this, instead of 10, I'm going to make this like 30, right? And then I'm going to graph it again. So here it goes. So it's tracing out. Now that's a nice parabola. Now, so basically we want to find the max. We can look here and see approximately where it is, but we can use the calculator to find exactly where it is. So the easy way to do that is go second, trace, and because we know that we're looking for a maximum, we go to option 4, maximum, boom. So you press maximum, and then, so it's gonna say, what's my left bound? Or basically it's saying, give me a point that's to the left of the maximum. So basically we would just go over, use the arrow key, and we're going to arrow over to the left of it, and then we're going to press enter, and then we're going to go, it's going to prompt you for the rightmost bound, right? So we're going to go past the maximum, and we're going to get to the right of it, and we're going to press enter again. Now it's going to ask you for a guess, and then we're going to say, boom, it finds the vertex, and it's telling us that the vertex is 10.20408, and that the y value would be 510.204. Now, if we go back to the questions, it says, what's the maximum height from the ground? The arrow will rise to the nearest meter. So in this case, we're looking for the y variable, or y coordinate. So it's going to be 510. So the answer here is 510. And then how long will it take the arrow to reach its maximum height? And we're going to find that to the nearest tenth. So you would go back to your calculator, and it's 10.2. So the answer here would be 10.2. And we're done. The only thing that you really needed to know in this question is basically which equation are you going to use? And because they're asking us for the maximum, right? We know that we're going to be dealing with a quadratic. And once we know that, the only other thing that we need is we just need to find the constant for initial velocity, and then the acceleration due to gravity, 9.8. Put those in, put the equation into your calculator. You don't have to do anything except type in the numbers, and then basically we're going to use the calculator, let the calculator find the maximum. And we're done with this one. It took us, although it took a little bit of time to do it for this problem, if I were doing this on the exam, it would probably take me a total of 20 to 30 seconds to answer this question. Answer both questions, okay? So again, here's just another example of how, if you know how to use your calculator strategically, you can get some of the more difficult questions very easily. All right, thanks.